Hey guys, so we're going to work on the pre-calculus fall semester exam review. We're going to start on problem 1. It says change 25 degrees to radian measure. Alright, so you should remember that you can change degrees to radians, radians to degrees, by simply thinking about the ratio of a circle. Okay, such as this is the idea, is that in a circle, 2 pi is the circumference, as is, or is the total number of radians in a circle, as is 360 degrees. Okay? So then 2 pi over 360 is just pi over 180. Okay? So now I need 25 degrees to change to radians, so I just multiply 25 by this. Alright? So I multiply 25 by this. Well, the degrees get to cancel out. So you get 25 pi over 180. You should remember, when you're multiplying a whole number to a fraction, you can put that whole number over 1 and top to top, bottom to bottom. 25 times pi is just 25 pi. And then 1 times 180 is just 180. So now we have 25 pi radians. I've been forgetting to write the word radians. I'm just going to put r, but in this case r is not a variable. It stands for radians. I just don't feel like writing out radians. Okay, now I can reduce 25 and 180. 5 goes into both. 25 goes into 5 goes into 25 5 times. So I get 5 pi radians over, let's see, 5 goes into 180. 5 goes into 18 3 times, maybe 15, 6, there we go. So we get that 25 degrees is the same as 5 pi radians over 36. Okay, so really the trick here is I tried to explain kind of like why we know it's 2 pi radians over 360. But the trick is just always remember that if you're changing degrees to radians, radians to degrees, you take the number we give you and you somehow multiply it by either pi radians over 180, or you multiply it by 180 degrees over pi radians. Okay, you just have to flip it depending on what we gave. If we gave you degrees, then you need degrees to be on bottom, so you put the 180 on bottom. If we gave you radians, you would need the radians to be on bottom, so you'd flip these. Okay? Alright, number 2. Change 2 pi over 5 radians to degrees. Okay, so we're just going to take 2 pi 5, just as I just said. We're not going to worry about trying to think about what it is in the scope of a circle. We're just going to say, okay, this is 2 pi over 5 radians. I'm just going to put r to stand for radians. So I multiply that by, alright, I will need degrees to be on top this time. 180 degrees over pi radians. Okay, so the radians get to cancel, as do the pi's. Now we multiply top to top, so 2 times 180 is 360. 360 degrees all over 5. Alright, and 5 goes into 360, let's see, 5 goes into 36, 7 times, carry down by 1, that's 10, that's 2, 72 degrees. So, 2 pi divided by 5 radians is the same thing as 72 degrees. Alright. Next problem. Find the measure of an arc of a circle of a radius 100 centimeters subtended by a central angle of 5 radians. Okay, so there's actually 2 different formulas we could use for this problem depending on if they gave us the angle in radians or degrees. They gave us the angle in radians, so then it's S is equal to theta r, where S is the measure of an arc, theta is the angle, and r is the radius. Okay? And I want to find the measure of an arc, so that means I can say S is equal to, I know that the theta is 5, I know that the radians is 100. And 5 times 100 is just 500, so the measure of this arc is 500. And that's it. That's all there is to this problem. Alright, number 4. A ladder that is 20 feet long leans against the side of a house. The angle of elevation is 7 degrees. How high up the wall of the house does the ladder reach? Okay, so we draw Alright, so it's a right angle problem because we assume that the ground and the building are perpendicular. I know that's not very always real lifey, but that's what we can assume in this problem. The ladder is 20 feet long, so this is 20. The angle elevation of the ladder, so that's this right here, is 70 degrees. How high up the wall of the house does the ladder reach? So this is x. Alright, so we have a right triangle, so we can use our trig ratio, SOHCAHTOA. Alright, we know 70 degrees. X in relation to 70 degrees is opposite, and 20 degrees is hypotenuse. Well, which trig ratio deals with opposite and hypotenuse? Well, SOHCAHTOA. So the one that deals with opposite and hypotenuse is which is sine. So I can say sine of 70 degrees is equal to x divided by 20. Now you got to solve for x. Okay? X is being divided by 20, so I can multiply both sides by 20. That allows these to cancel. So that's going to leave me with just x. And now I can just plug this side in a calculator. So be aware that your angle's in degrees, so that means your calculator needs to be in degree mode. Right now my calculator's in radian mode. So I'm going to go over here, I'm going to press enter. Second mode, jump out. 20 sine 70. Press enter. And I get 18.79, which I'm going to round up to 18.8. So 18.8. And there you go. That's all there is to this problem. Okay, next problem, number 5. Fort Worth is 33 miles from Dallas, and Hillsborough is 57 miles from Fort Worth. From Hillsborough, the angle between Fort Worth and Dallas is 20 degrees. What is the approximate angle between Fort Worth and Hillsborough taken at Dallas? Okay, so basically it wants us to find this angle right here. And you'll notice that I have myself a triangle that's not a right triangle, okay? So whenever I'm trying to solve something that's not a right triangle, I fall down to two things. I can either use the law of sines or the law of cosines, okay? This is a law of sines problem. I highly encourage you stop this video and try to think about why is it a law of sines problem. Okay, so hopefully you're just now unpausing the video. It's a law of sines problem because I have a pair, which a pair is a side and an angle that are opposite of one another, and I have half a pair, okay? So the 33 and the 20 degrees, this 20 is directly across from 33, so that makes it a pair. This 57 is across from the x, and that's half a pair, okay? So that means I only have one unknown that I could use in the law of sines. So I could say 33 over sine of 20 is equal to 57 over sine of x. Alright? So, now I need to solve for x. I look at this and I think to myself for a second, why did I put sine of x in the bottom? Not that I did anything wrong there, but really it'd be easier to solve for sine x if it was in the numerator instead of the denominator. So what I'm going to do is I'm just going to flip both sides. You guys should be aware that you can do that. You're not changing the problem, you're not doing something illegal, because what you do to one side, you're still doing to the other side. I am flipping both sides. So this is a completely allowed algebraic maneuver. Okay, sine x over 33. Okay, not 33, my apologies, 57. Okay, so now I need to solve for sine x. Well, first, I have to get sine x by itself before I can solve for x. So I'm dividing by 57, so I need to multiply both sides by 57. Okay, so that's going to cancel and that's going to cancel. And this is going to be some weird decimal number. So let's go ahead and get it off my calculator. So let's see here. It's 57 times sine 20. Now, if you were not in degree mode, you would need to make sure you change yourself to degree mode. I just changed myself to degree mode a second ago, so I know I'm doing okay. Press enter, and I get 0.59. Okay? Now, that's a rounded answer, and I'm actually not going to type that into the calculator. You'll see what I'm going to do in just a second. 0.59 is equal to sine x. Now, I want to solve for x, not sine x. So I use the calculator's sine inverse ability. So I'm going to take the sine inverse of both sides. Okay? Just as addition and subtraction and multiplication and division are opposites of one another, and they kind of undo one another, sine inverse and sine undo one another. Okay? So sine inverse and sine allow me to cancel each other out. So that's going to give me just x. Now I just need to go use my calculator to figure out what is sine inverse. So second sine. Okay. And now, if I had another fancy calculator, oh, this isn't going to let me do it. My lack of a fancy calculator means I cannot use the calculator's recall ability like you guys can. You guys could hit up arrow if you're using one of the school's calculators, and it would highlight this answer, and you could press enter, and it would put it in right there. I do not have that ability, so I actually am only going to, I'm going to type in 0.59076 just to give myself a little bit more, and I get 36.2. So it tells me then that the angle that's right here is 36.2 degrees. Alright, and that's what I was looking for. Next problem. Points A, B, and C are on one side of the river. Point A and B, sorry, are on one side of the river, while point C is on the other side of the river. It is known that the distance from point C to A is 117 feet, and the distance from point C to B is 212 feet. If angle ACB is equal to 65, what is the distance between point A and B? Okay, so let's set this up. So I have my river here. Alright. Tells me that point A and B are on one side, so we're going to call this A, we're going to call this B, and that point C is on the other side. Alright. So then we can set ourselves up a triangle. Alright. And it tells us that from point C to point A is 117 feet. Alright, so this is 117 feet. And from point C to B is 212 feet. Okay. If angle ACB, so angle ACB, that's this angle right here, is 65 degrees, what is the distance between A and B? So that's x. Alright. So this is a triangle. It's not a right triangle. Alright. So then that leaves me with either law of sines or law of cosines to solve it. To do law of sines, you have to have a complete pair. When you look here, nowhere in this problem do you have a complete pair. 212, we do not know the angle across from it. 117, we do not know the angle across from it. X, we know the angle, but we don't know the side. So we do not have a complete pair, so that leaves me with law of cosines. So the law of cosines simply tells us, the way we can use law of cosines, sorry about that, my brain died for a second. Law of cosine is simply the side you're trying to find, so in this case x squared, is equal to the other two sides summed together n squared, so 117 squared plus 212 squared, that's 212, minus 2 times those other two sides, so 117, 212, times cosine of the angle opposite the side you're trying to find. Alright? And what's great about this is now this is honestly just a calculated problem. If you can get this far, it's really the rest of this is just plug and chug. So 117 squared plus 212 squared minus 2 times 117 times 212 times cosine of 65. And we get this big number. You might be thinking that doesn't seem right because we're not done. That's what the side squared is equal to. So now what I need to do is I need to square root that answer. So what if I were you guys, I would hit second square root in your calculator and I would use your calculator's withdrawal ability like I'd press up arrow and then press enter to be more exact. I cannot do that on this calculator. So instead, I'm going to type out a few extra decimal places. 327. And I get 194.08. So x is equal to 194.08. Remember, I got x by square rooting both sides after I typed this long thing in the calculator. Alright? Next problem. Number 7. If sine x is equal to 0.2834 and cosine x is equal to negative 0.9590, then cosecant x is equal to what? Well, you should remember that cosecant is the same thing as 1 over sine. So then, honestly, this is a very simple problem. Grab your calculator. Simply do 1 divided by 0.2834. And we get 3.5. I'll say 3.53. 3.53. And secant x, you should remember, is the same thing as 1 over cosine. So, for this problem, we just grab our calculator. And we can type in 1 divided by negative 0.9590. Press enter, and we get negative 1.04. And there we go. Problem 8. Match the trigonometric equation with the correct graph. Okay, so let's let the calculator do all this hard work for us. Alright? Let's go to the calculator, let's go to y equals, clear out all this junk in here that you don't want. Alright, let's go back to this. And if I could get to move up, there we go. I don't want plot 1, there we go. Alright, I'm just going to type in 2 sine x, and then I'm going to show you how to adjust your window, okay? So 2 sine x, we're going to hit graph. Now first off, you notice my graph looks nothing like any of these. That's because I'm currently in degree mode. For some reason, calculators like us to do trig equations, sine, cosine, you know. When graphing them, they like to be in radian mode. So if I change it to radian mode and I hit graph, we're going to see it look a whole lot nicer. Okay. So one, you notice right away that the first equation is only going to match up with either C, not C, sorry, not, C is one of my answers. C or B. B and C are the only two because look here at the origin. This guy is crossing at the origin where A and D are not crossing at the origin. Not crossing through the origin, sorry. So the question becomes, which one is it? Okay, well let's adjust my window. You'll notice that both of these have a negative 2 pi to 2 pi on the x values, and they're both 3 to negative 3 on the y values. So we're going to go here to window. I'm going to change my x min to being negative 2 pi. I'm going to change my x max to being 2 pi. I'm just going to change my scale to being pi over 2. If you're really curious as to why I chose that, one, don't get hung up on the scale, okay? But if you're curious, I noticed that it took 1, 2 tick marks to get to pi, so pi over 2. 1, 2 tick marks, so pi. So pi divided by 2. Pi divided by the number of tick marks it took to get there. That's what I do my scale as. My lowest y value is negative 3. My highest y value is 3. And it's clear that each tick mark on the y scale is worth 1. Don't mess with the x res, just leave it alone. So let's hit graph now and see which one this looks the most like. So hopefully it's pretty obvious to see, oh, well C only had 2 humps and there's only 2 humps here. So number 1 matches up with C. So then hopefully it's pretty obvious to see that B is going to have to be this one right here because that's my only other sine one. So now it comes down to our cosine ones. Well, we're lucky that they all have the same windows. Look here, negative 2 pi to 2 pi, negative 2 pi to 2 pi, negative 3 to 3. So we just changed that. So if I do, go back to my calculator, go back to y equals, type in cosine of 2x, press graph, I can just compare which one is supposed to be. So when I'm looking between A and D here, it's pretty obvious that it's got to be A. Because this one has 1, 2, 3 humps. 1, 2, 3 humps. I mean, technically there's a hump here, and I guess you can kind of see it there and there. You'll notice the reason that I don't have these humps completely is because my calculator stops directly at negative 2 pi, and this graph technically goes a little past negative 2 pi. And same thing on the other side. So this one is A, so then by default this one must be D. Alright, moving on. Number 9. Which of the following trig functions are odd, which are even? I honestly suggest guys just memorize this. As far as like for a test goes, I think the easiest solution here is just memorize this. Okay? Cosine and secant are odd. The other 4 are even. Alright? Number 10. Simplify. 1 minus secant squared divided by tangent x. Okay. On the trig chart that we gave you, alright, we give you all of the trig identities right here. Alright? So if you're looking at that, go ahead and pause this video and pull that out. Okay, so you pulled out your trig chart, and you're looking at the Pythagorean identities now. And it says, you'll notice that there's a Pythagorean identity that says 1 plus tangent squared is equal to secant squared. So 1 plus tan, and we're going to manipulate this guy. I should put X here. Okay? We're going to manipulate this guy so that one side of it looks like this. Okay? Well, that means that we need secant and 1 to be on the same side, but I don't want to move the 1 over here because that would make the 1 negative. I don't want the 1 to be negative. I want the secant to be negative. So I'm going to take the secant and I'm going to move it over, but then I'm also going to take the tangent and move it over. So I get 1 minus, alright, so I'm moving the secant squared over, so it's going to go from being a positive secant squared to being a negative secant squared. Secant squared x. And then I move the tangent squared over, so it's going to go from being positive to being negative. Tangent squared x. Alright. And so now you'll notice that I can say 1 minus secant squared x is equal to negative tangent squared x. So that means I can replace this 1 minus secant squared x with negative tangent squared x. So I'm going to do that. So I'm replacing the 1 minus secant squared x with negative tangent squared x divided by tangent x. So now I can do some reducing because I have a tangent squared divided by a tangent. So tangent cancels out with that. So I'm left with just negative tangent x. And there you go. That's it. Alright. Number 11. Simplify. 1 minus sine x times 1 plus sine x. Okay, so the first thing you need to do here is to multiply these two out. You might say, why do I know to do that? Why do I not try to use any other identities and change stuff around? Because you'll notice that I don't have any squares here, and everything's in terms of sine or 1. That means there's really not a lot I can do as far as simplifying before multiplying. Okay? So we're going to multiply out. So 1 times 1 is 1. 1 times sine is sine. Okay? Negative sine times 1 is negative sine. Negative sine times sine is negative sine squared x. Alright, as I finish writing this, look at the middle there. Sine squared x, sine x, sorry. Sine x minus sine x cancels each other out. So I'm left with 1 minus sine squared x. Which now, you should think, ooh, that's a trig identity. If you look at your Pythagorean identities, you'll see there's one that says sine squared plus cosine squared is equal to 1. Alright, so think about that for a second. If you have sine squared x plus cosine squared x is equal to 1, how could you rewrite this so that one side of this looked like this? Well, yeah, I could just take the sine squared x and move it over. If I did that, I would get cosine squared x is equal to 1 minus sine squared x. And so then that would leave me with just, so that means I can change this guy to being cosine squared x. And I'm done. That's all that's required for that problem. Alright, let's go to number 12. Number 12 is the same type of problem. I'm going to need to multiply together first. So I get 1 times 1, which is 1. 1 times negative cosecant x, which is negative cosecant x. Cosecant x times 1, which is a positive cosecant x. And I get cosecant x times negative cosecant x, which is negative cosecant x squared. The middle two cancel, so I get 1 minus cosecant squared x. And now I'm going to go look at my trig chart again, and my Pythagorean identities again. Sorry, I said trig chart, I mean Pythagorean identities. And I see there that I have one that says 1 plus cotangent squared is equal to cosecant squared. 1 plus, and they use the variable u. You can say x, you can say u. The variable doesn't really matter. Is equal to, all right. So I need to think about how can I manipulate this so that one side of this equation looks like this. Well, what could I do? I can take the cosecant squared x and I can move it over, and I can take the cotangent squared x and I can move it over. If I did that, I would end up with 1 minus cosecant squared x is equal to negative cotangent squared x. Alright, so then this side looks like this, so that means I can replace this side with the negative cotangent squared x. So negative cotangent squared x, and there we go. That's cotangent, not lot. That's a c. Alright, and that's a square, not a 3. So negative cotangent squared x. Okay? Alright, number 13. Oh, I need to paste it. Okay, so apparently there's two number 12s on this paper. Not a big deal. The second number 12 says determine the period and amplitude for y is equal to negative 5 sine 2x. Alright, you should remember the amplitude is the positive number that multiplies to sine or cosine. So in this case, the amplitude is just 5. And you should remember that period is simply equal to 2 pi over b. b is the number multiplying to x. So in this case, that number is 2. 2 pi over 2, the 2's cancel, and you get just pi. And there you go. Amplitude is 5, period is pi. That's it. Number 13. Solve for 2 times cosine x minus 1 is equal to 0 for x on the unit circle. Alright, so that's not hard. First, we need to get cosine x by itself. So I'm going to have to add 1. So now I get 2 cosine x is equal to a positive 1. Now I'm going to divide both sides by 2. And so I'm going to get cosine x is equal to 1/2. So now I'm going to grab my trig chart. I'm just going to see where cosine x equals 1/2. So I'm looking at cosine. I'm looking at the column cosine. I see that it's 1/2 at pi over 3 and at 5 pi over 3. And so I can use both those answers. There's nothing restricting using both of those answers. So x is equal to pi over 3 and it's equal to 5 pi over 3. Okay. Number 14. Oh. Solve 2 sine x plus 1 times 2 cosine x plus square root of 3 is equal to 0 for x in the unit circle. This should look very familiar to your Algebra 2 problems where you had two quadratic pieces equaling 0, and then you set each piece equal to 0. So 2 times sine x plus 1 equals 0, and then 2 times cosine x plus square root of 3 is equal to 0. And so now we're going to solve for x in both cases. So in this case, we're going to subtract 1. Subtract 1. So we get 2 sine x is equal to negative 1. Divide both sides by 2. So we get sine x is equal to a negative 1/2. Which that's not hard to do. We grab our trig chart. We look at sine. Sine is equal to negative 1/2 at 2 places. 7 pi over 6 and at 11 pi over 6. So we get x is equal to 7 pi over 6 and 11 pi over 6. And then we need to go solve for cosine over here. So we're going to subtract square root of 3. Subtract square root of 3. So I guess it's 2 cosine x is equal to the negative square root of 3. Then we're going to divide by 2. Divide by 2. So that gives us that cosine x is equal to negative square roots of 3 over 2. So then I grab my trig chart, I go down cosine, and I see it as equal to negative square roots of 3 over 2 at 5 pi over 6 and at 7 pi over 6. Let me double check that. Yep, 7 pi over 6 and 5 pi over 6. Okay. So 5 pi over 6 and 7 pi over 6. And these are my 4. Now I say 4 answers, but technically there's only 3 different answers here, because you'll notice that 7 pi over 6 repeats. Alright, but these are my answers. Feet per second with the velocity of a ball thrown with an initial velocity of 70 feet per second and an angle of 40 degrees above the horizontal. Okay, so this should be something we just did. Hopefully you remember, okay, because we just talked about it in class the other day. But to find the horizontal component, it is just, sorry, I said 40. It is just magnitude times cosine of the angle. Guys, make sure you remember this is horizontal. Some of y'all missed it on this last test because you guys switched horizontal and vertical, okay? Horizontal is magnitude times cosine of the angle, which in this case is 40, okay? So that's just simply going to be, so we'll grab a calculator, turn it on. It doesn't want to turn on, so we're just going to close it because sometimes that helps. Alright, so 70 times cosine, whoop, I'm going to plug in degrees. Let's go make sure I'm in degree mode. Alright, I'm in degree mode. Second mode, jump out. 70 cosine 40, so that is 53.6. To get the vertical, you do 70 sine 40. And that is just simply going to be, grab a calculator, 70 sine 40. And you get 44.5. And so in component form, that's where you have the sideways V, the angle bracket as I call it, 53.6, comma, 44.5 angle bracket. So that means the horizontal is 53.6, the vertical is 44.5. Next problem. Given that u is equal to that and v is equal to that, determine the component form of the vector w if w is equal to u minus v. Okay? So basically all it wants us to do is to actually do u minus v. Okay? So then it's just simply going to be negative 5i minus j minus v. v is negative 2i plus 3. Alright? So now we need to subtract this. This is the biggest error I see, is that students forget that all of v becomes negative. So if it's already negative, it's going to turn positive, and if it's positive, it's going to turn negative. So 5i minus j. So negative and negative are going to make this a positive 2i, and negative and positive are going to make this a negative 3. So now I put like terms together. Negative 5i plus 2i is negative 3i. This should be plus 3j. I don't know why it doesn't have a j, but it should say plus 3j. Okay? My apologies for not catching that sooner. So then it becomes negative 3j, and then negative j minus 3j is minus 4j. Now, it actually asks us to do this in component form, not linear combination form. Okay? Linear combination form is I and j. Component form is where you do the angle bracket, horizontal component, vertical component, angle bracket. And there you go. Problem 18. Oh, I haven't pasted on here. Let me paste it on here. Give me just 1 second to do that. Okay, problem 18. Convert the pair of parametric equations, x equals t squared and y equals t minus 2, to a rectangular equation. Okay, so what you want to do here basically is you want to make an equation that just deals with x and y. And since this is a multiple choice test, I can already tell you. Now what you want to do is solve for t on the x equation. So you're going to solve for t on this x equation, and then you're going to plug that t value you get in for t over here, okay? So if x equals t squared, I can rewrite this equation as the square root of x is equal to t. So all I do is take the square root of both sides to get t by itself. So now I know that t is equal to the square root of x. So I come over here to where it says y equals, and I can plug in y equals. And I can plug this in for t right here. So y is equal to the square root of x minus 2. So y equals the square root of x minus 2. So now, just in case they change things up on you, okay, and they decide to give you a bunch of x equals equation answers instead of y equals, you can still do this the opposite way. You could go to the y equals t minus 2. Okay, so I'm going to do this one in orange now to show I'm doing the opposite way. But y equals t minus 2, I could solve for t by adding 2 to both sides. So I get y plus 2 is equal to t. So now I could take this y plus 2 and I could plug that in for t right here. So I could say x is equal to y plus 2 squared. Now I actually can square it out. That's going to be important to do. So that becomes y plus 2 times y plus 2. Okay, and then you're going to do first times first. So y times y, which is just y squared. And then you're going to do first times second, y times 2, which is 2y. And then you're going to do second times first, which again is another 2y. And then you're going to do second times second, which is 4. Now you just got to put like terms together, so you're going to get x is equal to y squared plus 4y plus 4. Just in case they go the other way and they give you a bunch of x equals equations, if they give you x equals equations, that means you need to solve for t on the y equals, alright, and then plug it in. Alright? Number 19. Consider a projectile launched at a height of h feet and above the ground at an angle of 30 degrees. The horizontal, the initial velocity v naught is in feet per second. The path of the projectile is modeled by the pair of parametric equations. X is equal to v naught cosine theta times t. Y is equal to initial height plus initial velocity sine theta t minus 16t squared. A ball is thrown from 0.5 feet above the ground with initial velocity of 85 feet per second. An angle of elevation of 20 degrees. Find the parametric equations that model problem situations. So it's all about plugging in. So x is equal to v naught, that's initial velocity, which in this case is 85, times cosine of the angle, which is 20, times t. We do not know what t is. We leave t as t. That's our new variable we care about. Y equals starting height, which tells me is 5 because the ball is thrown from 0.5 feet above the ground, so that's my starting height, plus initial velocity, which is 85, okay, times sine of the angle, which in this case is 20, times t minus 16t squared. And that's it. That's all I need to know for this problem. Problem 20. Convert the polar coordinate negative 5, 4 pi over 3 to rectangular coordinates, okay? So you should remember that x is equal to r cosine theta, and y is equal to r sine theta. Alright? So it tells me that if this is a polar coordinate, that means this is r and this is theta. So then it's just negative 5 cosine of 4 pi over 3. Alright, I do not want you to type that in the calculator. Cosine of 4 pi over 3 can be found on your trig chart. So you grab your trig chart and you see that cosine of 4 pi over 3 is a negative 1/2. I'm going to double check that because I just kind of glanced to make sure, but cosine 4 pi over 3, yep, negative 1/2. Negative 5 times negative 1/2 is a positive 5/2. Guys, we have to get good with fractions, okay? Y is equal to negative 5 sine of 4 pi over 3. Alright, sine of 4 pi over 3 is negative square root of 3 over 2. So we get y is equal to negative 5 times negative square roots of 3 over 2. Negative times negative makes us positive, so we're just going to get y is equal to 5 square roots of 3 divided by 2. And that's it. Okay? Problem 21. Convert the rectangular coordinate to polar coordinates. Okay, so we're just going the other way. So you should remember that r squared is equal to x squared plus y squared. Okay, and we know that x for this problem is negative square roots of 3 over 4. And we know that y is 1 over 4. Okay, now we've talked about several times how to square fractions. You square the numerator and then you square the denominator. So, negative square root of 3 squared is just a positive 3. 4 squared is 16. Plus, 1 squared is 1. 4 squared is 16. Alright, now I need to add fractions. Whenever you're adding fractions, you keep the denominator, assuming it's the same, which in this case it is, you keep it the same. And you add the numerator. 3 plus 1 is 4. And 4 over 16 can be reduced down to 1/4. Now that is r squared. To get r, I need to take the square root of both sides. So the square root of 1 over the square root of 4. So then r is equal to 1/2. Okay, now I need to get theta. So tangent theta is equal to y over x, so in this case 1/4 over negative square roots of 3 over 4. So you need to keep flip change. So tangent theta, you keep the numerator as 1/4, change from division to multiplication, and then flip the denominator, square roots of 3. Cancels, cancels, so you get 1 divided by the negative square roots of 3, which hopefully you realize you can't keep, because that would have a square root in the denominator, which I can't have. So I have to multiply top and bottom by square roots of 3. So don't forget this negative sign. A lot of us lose sight of this negative sign. Don't forget it, okay? So now we have tangent theta is equal to square root of 3 over negative 3. So I'm just going to pop the negative out here to the side. So now I grab my trig chart. I see where tangent theta is equal to the negative square root of 3 divided by 3. In two places, 5 pi over 6 and 11 pi over 6. So how do I choose which theta to use? Because I can't use both. Alright, so the way you determine that is by looking and seeing go back to your original point, your xy point. What quadrant did this follow? Negative x, positive y. That's quadrant 2. Which of the two angles, 5 pi over 6 and 11 pi over 6, that we just saw that tangent theta equaled negative square root of 3 over 3, which of those two angles, 5 pi over 6, 11 pi over 6, would make you fall in quadrant 2? 5 pi over 6. So we go with 5 pi over 6. So then, this rectangular point is equivalent to the polar point 1/2, comma, 5 pi over 6. Alright, next problem. The polar equation r equals 4 theta represents a spiral. You can get that from your calculator. Turn your calculator on. Go to mode. Change your calculators from being in function mode to polar mode. Oh, I went too far. Press enter. Go to y equals 4. Spell right there. Theta. Hit graph. And I'm in degrees. Let's go back and change to radians. And that's clearly a spiral. Alright, next problem. 24. Evaluate the parametric equations x equals t minus 5 and y equals t squared for t is equal to negative 2. Guys, all that means is plug in negative 2 for t in both cases. So then x is going to equal negative 2 minus 5, which is going to be negative 7. And then y is equal to negative 2 squared, which is just 4. So then that gives me the point negative 7, comma, 4. And there we go. Alright, next problem. The graph of the set of parametric equations x equals 4 sine t and y equals 4 cosine t. Alright, so this is parametric, so you want to go change your mode to being in parametric mode. Go back to y equals, change this to being 4 sine t, and then 4 cosine t. Hit graph. Now, this is an important part. You need to hit zoom 0. You can start with zoom 6. I just reset my calculator, so that's why I didn't hit zoom 6. But if your calculator is not reset, I do suggest starting on zoom 6, then doing zoom 0, and then doing zoom 5. And you'll see that this is clearly a circle. Alright, problem 26. Convert the rectangular equation y is equal to x minus 1 divided by x using t equals x minus 1 as the parameter. Alright? So, for the sake of time, I'm going to show you all some fast way of doing this. Alright? It says y equals x minus 1 over x. Well, t is equal to x minus 1. So I know then that this numerator can be replaced by t. So, t divided by. Now what I want to do is replace this x with somehow with t. So I'm going to go over here and I'm going to add 1 to both sides real fast. Add 1. Add 1. And I'm going to get that if I was to add 1, I would get t plus 1. So x is equal to t plus 1. So I'm just going to put t plus 1 down here at the bottom. Alright, and I'm done. That's it. I got my rectangular equation. Problem 27. I need to pop it in here. Problem 27. Which trig functions have asymptotes at pi divided by 2? Guys, we don't need to make this problem hard. We don't need to go looking at graphs. Grab your trig chart. Go to pi over 2 and just simply see which trig functions are undefined at pi over 2. That just simply means they have asymptotes there. And we clearly see that it's tangent and secant. Alright? So, tangent and secant. I'm not even going to write it out. Tangent theta, secant theta. You can write that out. Okay? Problem 28. In which quadrant of the unit circle is tangent less than 0? In which quadrant of the unit circle is tangent greater than 0? Okay. The trick to this problem is to remember that tangent is really y divided by x. Y divided by x. So, what does it mean to be less than 0? It means to be negative. How can a fraction be negative? That's if 1 is positive and 1 is negative. Which quadrants is 1 positive and 1 negative? Well, I know in quadrant 2, x is negative, y is positive. So if I did positive divided by negative, that would make it negative. So quadrant 2 and then quadrant 4, because I know in quadrant 4, x is positive, but y is negative. And then to be greater than 0, it means that both of these are positive or both of these are negative. Okay, because that would make it greater than 0. Because that means to be greater than 0, you're positive. Okay, so that's just quadrant 1, where x and y are both positive, and quadrant 3, where x and y are both negative. Alright, problem 29. Use the calculator to solve for angle A and the equation cosine A is equal to that. Alright, this is just simply grab the calculator, turn it on, hit, it needs to be in degrees. I'm glad that it specified that. So now we're in degrees. We hit second cosine, and we just type in negative 0.8613. Press enter, and we get 149.5. 149.5 degrees. Alright. Problem 30. The sonar of a Navy cruise detects a submarine that is 3,000 feet from the cruiser. The angle between the water level and the submarine is 23.5. How deep is the submarine? Alright, so we have a ship above water, so we're just gonna make that a point. So here's my ship above water. It detects some kind of cruiser that is 3,000 feet away. Alright. And then there's some water going on right here. So we're going to call this water. Let me do this. Draw another line connecting them. And it says the angle between the water level and the submarine is 23.5. So this right here is 23.5. Because here's my water. So this is kind of like my point for the water. And here's my line. So this is understood that this is 23.5. It's going to be hard to write. Hold on. Let me erase some of this and try drawing this again. Alright. So, Okay, I paused the video to try to get Joss a little bit better. And I think at the, right before I paused this video, I accidentally said that the angle was right here. But this is where your angle would be. Alright, so this is where the angle is 23.5 degrees. Alright, that's a 23, not a 27. Okay, so 23.5 degrees. Alright, and it says, how deep is the submarine? So that would be X right here. Okay, so, because the reason this is the angle is here's your water level. So then the angle going down to get to the submarine from the water level is 23.5. So that's why this is 20. That's why your angle is right here. Okay. So I need to find x. It's a right triangle, so I can use my trig ratios. Okay. In reference to 23.5, what is x? It's the opposite. The 3,000 is my hypotenuse. So we just did this problem earlier. We just did different numbers. It's sine again. I know that sine of 23.5 is equal to 3,000. Oh, nope. Sorry. X divided by 3,000. For the sake of time, because I have detention duty in about 10 minutes, so I need to try to finish this video as fast as I can, multiply both sides by 3,000 and plug that in the calculator. So, we're going to turn our calculator on. It's already in degree mode. If it wasn't, I'd go change it because they gave me 23.5 in degrees. Press enter, and I get 1196.2. So x is approximately equal to 1196.2. Alright, problem 31. Okay, problem 31. A plane is flying at 30,000 feet, spots an airship off in the distance. The angle of depression from the plane to the ship is 42 degrees. What is the distance from the plane to the airship at that moment in time? So, here's your airplane. He is looking out, and then he looks down to create your angle of depression here at the airport, at the airstrip. So here's the airstrip. So I'm going to say that this is a hypothetical straight line right here, which would make this a 9-degree angle. This is 42 degrees. Okay, so please try to draw this prettier than I am. Alright, you should pause this video and try to do the rest of this problem. Seriously, pause it. Do the rest. Hopefully you just unpause the video and you're saying, okay, so then this is 30,000. Okay. So then it's pretty easy. It says, what is the distance from the plane to the airstrip? That's x right here. So you would say, okay, so here's 42 degrees. I know the opposite, and I want to find the hypotenuse. Opposite and hypotenuse, it's like we love sine right now. Because this is sine. This is another sine of 42 is equal to 30,000 over x. Now, when I look at this problem, I see that x is in the denominator. I don't want x to be in the denominator, so I'm going to do that trick I did earlier. I'm just going to flip both sides. So 1, I'm going to remember that sine 42, I can say is over 1. So now I'm going to flip it to being 1 over sine of 42. And then I'm just going to flip the other side to being x over 30,000. And now I'm going to solve for x by multiplying both sides by 30,000. Alright, so I'm going to grab a calculator. I'm going to type in 30,000 times 1 divided by sine of 42. I'm already in degrees, otherwise I'd go change my calculator to being in degrees. Press enter, and I get that the distance is approximately, I don't know why I was going to draw another equal sign. The distance is approximately 44,834. 8, 3, and there we go. Alright, problem 32. Simplify cosecant x times secant x. Sine x plus cosine x. Alright, so we're multiplying these two times this. Here's the trick. Remember that this right here is a block, okay? Cosecant x times secant x. They are married. You cannot just separate them willy-nilly, okay? Also remember, what is cosecant x the same as? It's the same as, oh shoot, my brain's forgetting. Sorry. Cosecant x is the same thing as 1 over sine. I knew that. I don't know why I didn't say that. Cosecant x is the same thing as 1 over sine, and secant is the same thing as 1 over cosine. So when you multiply this guy into the parentheses, you're distributing this block into it. So when you multiply this guy here, the cosecant, which is the same thing as 1 over sine, cancels out with sine. Okay? Because, in fact, I'll just write it all out. I think I have an extra moment. Cosecant x, secant x, sine x. Alright, so now all three of these guys are multiplying. Plus, and then you're going to multiply this guy to cosine x as well. Cosecant x, secant x, cosine x. Alright? And then what do we remember that cosecant x is really the same as? 1 over sine, right? So 1 over sine. So all I'm doing now is just changing I'm just changing cosecant x to being 1 over sine x. Alright? And all three of these guys are still multiplying. There's still multiplication going on. Still multiplication going on. If you want to go back and add in multiplication signs, that's fine. I'm going to change I'm going to keep cosecant as cosecant because there's no reason to change it. But secant, you should remember, is the same thing as 1 over cosine. Times cosine x. So then you should notice here, hey, these cosines will get to cancel. Hey, these sines will get to cancel. So you're left with secant x plus cosecant x. And there you go. That says cosecant, CSC. That was some really bad handwriting, but that's what that says right there, CSC. Alright, problem 33. Which of the following is not equal to sine 30 degrees? Alright, cosine 60. Alright, well first off, what is sine 30? Sine 30 is 1/2. Cosine 60, I'm just looking at my trig chart. Sine 30 tells me is 1/2. Cosine 60 is 1/2, so that one does equal, so it's not my answer. Sine negative 330. Alright, so let's think about this for a second. What is it to be negative 330? That means to go around the unit circle in the opposite direction 330 degrees. Okay? So, to go around negative 330 degrees, well, that would actually put you right back at 30 degrees. So it's not going to be that because that actually ends up being the same spot. Okay? You can actually also check it with a calculator. I'll just show you real fast. I'm actually probably making your life harder by saying all this. You can just have typed in negative sine 330. Bam, 0.5. And you can check sine 30 is 0.5. So what is tangent 30? Let's see if this one will do it too. It should, assuming it's a nice number because it's a nice number like 0.5. Sine 30. We do not get 0.5. So I suggest that you check this last one, just to be sure. Tangent 30, cosine 30. Press enter, and you get 0.5. So then the only one that's not like that is C. Alright, one last problem to go. I accidentally skipped over 2 problems when I was working out this. One, I skipped over problem 23, and I'll tell you why. We never covered getting the equation of hyperbola in class, and so I'm not going to ask you to worry about it. Alright? I'll just, if it's on the exam, I'm just going to give you that problem. I'm not going to worry about it. However, I skipped over 15 because I'm not sure I ever addressed a problem exactly like this, but it's definitely still a doable problem. Okay? So I do kind of still expect you guys to be able to figure it out. Alright? It says a pilot flies a plane due north heading 0 degrees for 2 hours at 250 miles per hour. Okay, first pause and think about how many miles that is. Okay? That's 500 miles. That's an important piece of information. We'll talk about why in a second. Alright, the pod then changes course to a heading of north 44 degrees east and continues flying for 1 hour 200 miles per hour, which again would be 200 miles. What is the straight line distance from starting to ending location of the plane? Okay, so first off, we have this dude who starts here and he flies straight for 500 miles. He then turns 44 degrees and flies in this direction for 200 miles. First off, this 44 degrees is not inside here. It's actually right here. Okay? And it wants to know what is the straight line distance from here to here. So basically it's trying to find this x right here. Well, if we know this little angle right here is 44 and this is a straight line, I know that a line has to add up to be 180 degrees. So then I know this part of the angle is just 180 minus 44, which is 136. So this angle right here is actually 136 degrees. Okay? So then, this is a perfect law of cosines problem. I have the angle across from x. I don't have any other angles. I know the other two sides. So I could just say x squared is equal to 500 squared plus 200 squared minus 500. I should have put that in parentheses. Oh well, it's not a big deal. I'll put this one in parentheses. Times 200 times cosine of the angle opposite the side I'm trying to find. So that's 136. So this is all now a calculator problem. So I grab my calculator and I do 500 squared plus 200 squared minus 500 times 200 times cosine. I already know I'm in degree mode, but if I wasn't, I would go change myself to degree mode. Press enter, and then I need to square root that number. Again, if I had your calculator, I'd just press arrow up, press enter after I did that to just automatically recall it back into the problem. 0.98. Close it, press enter, and I get 601.6. So x is approximately equal to 601.6. Again, I'm not sure we ever covered this exact problem in class, but it's not a hard problem, guys. It's really not. The trick is just remember that angle that gets made is not inside the triangle, it's outside the triangle. So you have to subtract 180 from it. And then it's just a law of cosines problem. Okay? I know this is a long video. Let me know if you guys have any questions. Please watch it. Okay? Please watch it.